Hey geometry students, it's Mrs. Young. Today we are going to work on an interactive notebook page for symmetry. This goes with lesson 1.2.6 from your book. You are going to need your interactive notebook page, your interactive notebook, some tracing paper, and a pencil because pencils work best on tracing paper, and then if you want to use a pen for the notes portion, you can certainly do that. So we've got two types of symmetry that we are going to talk about today. One of them you are very familiar with. The first one is line symmetry. So two-dimensional figures have reflection or line symmetry. We're going to go ahead and write reflection. If you can draw lines, it could be one, it could be more, through the figure so that one portion of the figure is the mirror image of another. It is possible for a figure to have more than one line of symmetry. So we're really familiar with this. We've done this many, many times before we started working on line symmetry or reflection symmetry in elementary school, but there are going to be a few tricky shapes. So if you are uncertain if your shape has a line of symmetry, you can go ahead and use tracing paper to trace your shape and then test to see if it has a line of symmetry. So this semicircle actually looks a little wonky to me. I'm not sure if it does have a line of symmetry. I'm guessing it's right about there, so I'm going to sketch it in and we'll see if the pieces match up. So we're going to try to fold right on that line. Yeah, that does not match up. So can you see how my two halves don't quite meet up? So that means that this does not have a line of symmetry, okay? Equilateral triangle, that one's pretty obvious. So we can go ahead and draw in 1, 2, 3 lines of symmetry. The cloud is not going to have any lines of symmetry because we have kind of these different parts around. It does not look like we can fold anywhere and get that to match up. All right, we've got a line of symmetry here for the shape. Now this one, it looks like we could get a couple of lines of symmetry. So I could do one here, and then I could do one there. The lightning bolt, I do not believe will have a line of symmetry, but again, that's something that if you're not sure of, you can go ahead and trace it on tracing paper and then see if you can fold and get the pieces to match up. But I don't think that it will. Nope, so my corners right there are not lining up when I try to fold it in half. So on those shapes that don't have lines of symmetry, you can just write none. That way I know that you actually looked at it and thought about it. All right, let's see if the next one has some lines of symmetry. So I think I could fold it down the middle and then down the middle, and then I kind of wonder if we could fold it there. So let's test out some of those ideas. So I'm gonna guess that there's a line of symmetry here. I'm gonna guess there's a line of symmetry there. And then I wonder if we can go here and here and here and there. So let's test those out and see if it works. See if we can kind of fold it every which way on those pieces that look symmetrical. So let's try. I'm gonna move it out from under the camera for a second so I can actually see what I'm doing to line it up. All right, so that is looking pretty good when I fold it down the center like that. And then I'm gonna go through and check the other ones as well. And hopefully you are following along and trying this out at home. So I've got my vertical and my horizontal checked out. Looking good there. I'm gonna check some of my diagonals. Maybe you can see it. Maybe I'm getting more talented at folding as we go here. So I'm kind of wondering, that diagonal does not look so good. So those are not matching up. I was hoping that that would match, but you can see that those are a little bit off. Try it that way. I'm gonna move it again so that I can make sure I'm lining up what I wanna line up. Yeah, so those are just not matching up when I tried to do on the diagonals. All right, and then we get to an easier one. So this one we could definitely fold like this, and we could definitely fold like that. And again, let's check out and see what happens with those diagonals. Can we make it work on a diagonal with this shape? I don't know. So let's trace it and then test it to find out. So this tracing paper is a really nice tool, and you are able to use it on your state tests. So you can get comfortable using it as we do assignments and tests and anything that we work on in class, and you will still get to use that when we do our state testing. Okay, now on this one, the diagonals are working out, unlike that star. Okay, so I'm gonna go ahead and add those lines of symmetry here and there. Okay, so again, that's something that you are hopefully familiar with from elementary school. The second type of symmetry I think is new for you guys. So two-dimensional figures have rotational symmetry. If you can rotate the figure around its center a certain angle, which means a certain number of degrees, so that after the rotation it appears exactly the same as before the rotation. The order of rotation symmetry is the number of times the figure lands on itself during a 360-degree rotation. The degree of rotation symmetry is the number of degrees needed for the figure to rotate onto itself. Okay, so we'll talk about both of those as we go. So if we look at our square, what we're gonna do is pin it down at its center, right there. And then we're gonna count, I'm gonna mark like a little star. This was the top. That way I know when I get back to the beginning. And we're gonna rotate this and see how many times it lands in its original position. Now, if you didn't hit it exactly center, it's gonna be a little off. All right, so that's 1, 2, 3, and then by the time we get back to 360, it has landed in its original position 4 times. That is the order of rotational symmetry. So this one has an order of 4. And then the degree of rotation symmetry is going to be 90 degrees. So we can figure that out 2 different ways. So we could visually see when we turned it 90 degrees that landed in its spot, but 90 degrees is a really easy number to work with. The other way that we can figure it out is to take 360 degrees for a full turn and divide it by the order, and we get 90 degrees. Okay, so on the next one, we've got an equilateral triangle. So we're gonna go ahead and trace that. And again, I like to mark the top just so I know when to stop when I've gone my full 360 degrees. On most shapes, it's not too difficult to tell, but on some of the more complex ones it is. Okay, so there's 1, 2, and then 3. So this is gonna have an order of rotation symmetry equal to 3. And then to get the degree of rotational symmetry, we can just do 360 divided by 3, which is 120 degrees. All right, so the heart, if we trace that and spin it around on its center, and notice this one little sheet of tracing paper is getting me through this whole resource page. So go ahead and use like every little piece of it that you can. All right, I know what the top of my heart looks like. So I'm gonna spin this around and see if it looks like the original at any point. And it does not until I get all the way back to the beginning. So that has an order of 1, and that's really nothing special because you can do that with any shape. So we really don't consider that to be rotational symmetry because every shape can do that. So that one's not really special in any sort of way. All right, so we're gonna continue on. Now you're gonna get to a point where you can recognize that this is not gonna have rotational symmetry. But if you need to check it out, like if you're taking a test and you just wanna be 100% sure, feel free to go ahead and trace it and check it anyway. But again, that one's nothing special, really no rotational symmetry. It didn't land on itself until it got back to 360. All right, now these circles, those are ones where I would definitely mark where the top was because it's a little tricky to tell when you get back to the beginning. Okay, so I'm gonna pin it down. Okay, so it looks like 1, 2 times. So the order is going to be 2. And then the degree will be 360 divided by 2, or 180 degree rotational symmetry. And that one's one that you could probably recognize that it was a half turn or 180 degrees before you got it to match up with itself. Okay, so then sometimes kids start to notice, well, we have these 4 points on our square, and the order was 4. We had these 4 points on our triangle, and the order was, we had 3 points on our triangle, and the order was 3. And now we get a hexagon that has 6 points, so the order is going to be 6. And then the degree of rotational symmetry would be 360 divided by 6, or every 60 degrees. And then on this shape, we've got 1, 2, 3, 4 sections to it, 4 little points coming out of it. So you don't have to use your tracing paper, but if you want to check, you can. All right, so the order of rotational symmetry would be 4, and then we saw up here when the order was 4, the degree is 90, or 360 divided by 4 is 90. And then this one would work the same way. But again, if you want to check with that tracing paper, you are more than welcome to do that, and you may use that on your tests. All right, so what you guys need to make sure that you do is get this into your interactive notebook, glue it down, and update your table of contents. You can call the title Symmetry.